Most people think the future of green hydrogen will be decided inside electrolyzers. Bigger stacks, higher efficiencies, cheaper catalysts, more gigawatts. But that may be the wrong way to look at the hydrogen economy entirely. Because underneath nearly every major hydrogen announcement is another system most people barely notice. Ports. The hidden industrial gateways that quietly determine whether hydrogen becomes a globally traded energy system or remains trapped inside isolated regional projects. And right now, one of the clearest examples of this hidden reality is emerging in South Africa through a massive $5.8 billion green ammonia megaproject linked to the port of Coega. On the surface, the story looks simple. A large green hydrogen and ammonia project is moving forward using technology from topsoil, targeting roughly 1 million tons of green ammonia production annually. Politicians call it a clean energy breakthrough. Industry groups call it a decarbonization milestone. But the real story may have almost nothing to do with hydrogen technology itself. The deeper story is about industrial geography, shipping routes, infrastructure corridors, export logistics, and the hidden systems that determine whether energy can move across civilization at scale. Because hydrogen has a problem the industry still struggles to fully confront. It is extremely difficult to transport economically. Hydrogen is the smallest molecule in existence. Its volumetric energy density is very low unless compressed or liquefied. It leaks easily, it embrittles metals. Liquefaction consumes enormous amounts of energy. Storage systems are expensive. Every stage introduces complexity. Every stage introduces losses. And once you begin analyzing hydrogen at global scale rather than laboratory scale, you realize something uncomfortable. Producing hydrogen may not be the hardest part of the hydrogen economy. Moving it may be. That changes everything. Suddenly, this is no longer just an energy story. It becomes a logistics story, a maritime infrastructure story, a fertilizer story, a geopolitical trade story, a port story. And once you understand that, South Africa's strategy becomes far more sophisticated than it first appears. The port of Coega is not simply a convenient location near renewable resources. It is a strategic industrial node positioned near one of the world's most important shipping corridors. The project is attempting to connect renewable electricity, electrolysis, ammonia synthesis, export logistics, and global trade into one integrated industrial system. That distinction matters enormously because most hydrogen discussions still focus on technology in isolation rather than the infrastructure ecosystems required to support it. And this is where ammonia enters the picture. Hydrogen itself is difficult to transport. Ammonia is not easy either, but civilization already built a global system around it decades ago. The fertilizer industry ships ammonia worldwide. Ports already understand how to handle it. Storage tanks already exist. Maritime regulations already exist. Shipping infrastructure already exists. Industrial buyers already exist. That means ammonia may become the practical transport layer of the hydrogen economy. This is one of the biggest hidden shifts happening in clean energy right now. The future hydrogen trade system may not actually trade hydrogen directly at scale. It may trade ammonia instead. That possibility completely changes the competitive landscape. Countries that possess strong port infrastructure, export capacity, industrial zones, and maritime access suddenly gain a major advantage. The future winners of the hydrogen economy may not necessarily be the countries with the best electrolyzers. They may be the countries with the best industrial logistics systems. And that is why South Africa matters. South Africa sits at a strategic intersection between renewable potential and global shipping access. It has world-class solar resources, strong wind potential, large industrial land availability, existing heavy industry expertise, and crucially, maritime positioning capable of supporting export-oriented industrial systems. The Coega project is attempting to transform those advantages into a new economic model built around green molecules. But here's where the story becomes even more interesting. Because the project is not just about energy exports, it is also about reshaping industrial trade flows. For decades, global energy trade revolved around oil, LNG, and coal. Massive infrastructure systems were built around these commodities. Pipelines, refineries, LNG terminals, tanker fleets. Entire geopolitical relationships emerged around fossil fuel logistics. Hydrogen introduces a very different challenge because transporting pure hydrogen at global scale remains difficult and expensive. But ammonia potentially creates a bridge between renewable energy production and existing industrial trade systems. That means ports become civilization-scale energy conversion hubs. The port is no longer just a place where ships arrive. It becomes a hydrogen production center, an ammonia synthesis center, an energy storage center, a maritime fueling center, and an industrial export platform. In other words, the future energy transition may physically concentrate around ports. And this creates another major shift. Hydrogen projects are beginning to resemble industrial ecosystems rather than standalone energy facilities. Think about everything required for a project like Coega to function: renewable electricity generation, grid integration, water sourcing, desalination potentially, electrolyzers, compression systems, ammonia synthesis loops, storage infrastructure, export terminals, shipping coordination, long-term offtake agreements, financing structures, insurance, certification systems, carbon accounting, maritime logistics, heavy industrial labor, maintenance ecosystems, transmission infrastructure. This is not simply an energy project. It is an industrial civilization project. And that introduces enormous complexity. Because the hydrogen industry is now entering what may be called the execution era. For years, hydrogen announcements focused heavily on ambition. Countries announced strategies, companies announced gigawatts, startups announced breakthroughs. But now the industry is approaching the stage where projects must survive real economic conditions. And that is where things become difficult. Electrolyzers are expensive assets. If utilization rates fall, hydrogen costs rise dramatically. Renewable intermittency creates operational challenges. Electricity pricing volatility creates financial risk. Interest rates affect project bankability. Infrastructure delays create bottlenecks. Transmission constraints reduce utilization. Water availability becomes critical in some regions. Long-distance shipping introduces additional cost layers. Suddenly, the problem is no longer simply, can we produce green hydrogen? The problem becomes, can this entire system survive under real-world industrial stress? That is the question investors are now asking. And this is why ports matter so much. Ports help solve one of hydrogen's biggest risks: demand uncertainty. Export infrastructure connects projects to larger global markets, rather than forcing them to depend entirely on local consumption. That flexibility may become critical for project survival. Because the hydrogen economy is increasingly revealing a brutal economic truth, utilization matters more than nameplate capacity. A giant electrolyzer operating at poor utilization can become a financial disaster. This is one reason the Coega project is receiving so much attention. It attempts to combine renewable resources with export-oriented infrastructure capable of connecting South Africa to future global ammonia demand. And those demand signals are growing. Shipping companies are under pressure to decarbonize maritime transport. Heavy industry faces increasing emissions constraints. Fertilizer systems are exploring low-carbon ammonia pathways. Governments are introducing carbon border mechanisms. Industrial buyers are seeking cleaner supply chains. Data centers and AI infrastructure are increasing electricity demand worldwide, intensifying pressure on energy systems. All these systems are beginning to collide. That collision may define the next phase of industrial decarbonization. And hidden inside that collision is ammonia. Ammonia is fascinating because it sits at the intersection of multiple trillion-dollar systems simultaneously: energy, food, shipping, industry, and geopolitics. The global fertilizer industry already depends heavily on ammonia. Agriculture depends on fertilizer. Food systems depend on agriculture. Maritime shipping is now exploring ammonia as a future fuel. Hydrogen projects increasingly use ammonia as an export carrier. This means ammonia could become one of the most strategically important industrial molecules of the 21st century. And if that happens, ports become even more important. Because the countries capable of exporting green ammonia efficiently may gain major industrial advantages. But none of this is guaranteed. This is where the Renewable Energy-style system's stress lens becomes critical. Hydrogen projects often look impressive in presentation decks, but industrial reality is much harsher. Projects must survive. Low utilization, fluctuating renewable generation, weak demand periods, infrastructure delays, high capital costs, policy changes, and global commodity volatility. The history of energy transition shows that infrastructure determines winners and losers. Oil required pipelines and ports. LNG required liquefaction terminals and regasification infrastructure. Coal required rail systems and export terminals. Every energy transition creates infrastructure choke points. Hydrogen will likely do the same. And one of the biggest choke points may become ports capable of integrating renewable energy, industrial production, and global shipping into coherent export systems. This is why countries around the world are now racing to build hydrogen-linked industrial port ecosystems. Saudi Arabia is pushing massive export-oriented hydrogen systems linked to maritime trade routes. Australia is developing ammonia export strategies tied to Asian markets. Europe is positioning Rotterdam as a future hydrogen import hub. Singapore is exploring ammonia bunkering infrastructure. Chile is pursuing export-oriented renewable hydrogen development. Morocco is positioning itself as an energy bridge into Europe. This is no longer just about climate policy. It is about future industrial geography. Who controls the export corridors of future energy molecules? That may become one of the defining geopolitical questions of the next 2 decades. And South Africa wants to be part of that answer. But there is another hidden layer here most people miss entirely. The hydrogen industry increasingly talks about electrolyzer costs, but the real economic challenge may actually be system integration costs. Connecting all the layers together, renewable generation, grid infrastructure, water systems, transmission, storage, export terminals, shipping contracts, industrial buyers, certification systems. This is why so many hydrogen projects stall before a final investment decision. Not because the chemistry fails. The chemistry already works. Electrolysis works, ammonia synthesis works, maritime shipping works. The problem is systems coordination. Civilization-scale infrastructure is difficult. And that is exactly why the Coega project matters so much. It represents one of the clearest attempts to move beyond isolated hydrogen pilots toward integrated industrial infrastructure. If successful, projects like this could reshape global trade flows. Countries with abundant renewable resources could export embedded green energy through ammonia. Industrial supply chains could gradually decarbonize. Maritime transport could transition toward lower carbon fuels. Fertilizer systems could reduce dependence on fossil fuels. Entire industrial corridors could emerge around renewable energy exports. But if projects fail economically, the consequences could be severe. Investor confidence could collapse. Financing could tighten. Governments could reduce support. Infrastructure deployment could slow. Hydrogen could become trapped in perpetual pilot project mode. That is why the next 5 years may be decisive. The hydrogen economy is approaching a moment where ambition must confront industrial reality. And industrial reality is ruthless. The projects that survive will likely not be the ones with the flashiest presentations or the biggest electrolyzer announcements. They will be the projects capable of integrating energy systems, logistics systems, shipping systems, and industrial demand into economically resilient infrastructure networks. In other words, the winners may not simply build hydrogen plants. They may build entire industrial ecosystems around ports. And that is the hidden reason South Africa's $5.8 billion hydrogen project matters so much. Because beneath the electrolyzers, beneath the ammonia headlines, beneath the clean energy marketing, the project may actually represent something much larger. An early blueprint for how civilization could restructure global energy trade around renewable industrial molecules. And if that transition truly happens, ports may become the most important hidden infrastructure layer of the entire hydrogen economy. If you want deeper analysis on hydrogen economics, industrial infrastructure, ammonia trade systems, and real-world project survivability, explore H2 Hub by Renee Energy, where developers, consultants, investors, and industrial operators learn how hydrogen projects survive under real system stress.